Okay, so for this example, I'm going to show you how to find the apportionments using Excel. This is the same problem that you had where I showed you how to do it by hand. So you do have those videos of how to calculate all of this by hand. But Excel, we realized, might make it go a little bit faster. So I decided to throw this video up so you guys could see, especially when we get to the project next week. Being able to use Excel, I think, will help you quite a bit. So first of all, one of the first things that we're going to need to find is the standard divisor. So in order to find the standard divisor, I actually need the sum of all these populations, and Excel will do that for me. If I just type equals sum, open parentheses, and then highlight these 4 cells that you want the sum of, close parentheses, and press enter. Or you can, of course, just type them in. Now, if you remember, this particular country had 100 seats that they were going to apportion. So to find our standard divisor, I'm going to say equals, and our sum of our population is located in cell B6, so I'm going to type B6, divided by 100, since that's how many seats I'm trying to give out, and there's my standard divisor. So now let's take a look at our quotas. Type equals, and the population for state A is in cell B2, divided by the standard divisor, which is in cell B8. The thing about the standard divisor is I want to anchor it. What happens when I anchor it is I'm actually going to drag this formula down. I'm only going to type it in once. And I don't want the standard divisor to change. However, I do want the population to change with each cell. So I'm going to anchor cell B8 by doing $B, $8. And now so I'm going to press enter, 9.36. And if I come to the bottom, click on cell C2, come to the bottom right corner here and click and drag it down. Notice what happens in my formula bar here is I went from having B2 divided by B8 to B3 divided by B8, B4 divided by B8, B5 divided by B8. And so it took care of that for me. And so anchoring the cell there was very helpful. All right, so we're going to come up with what Hamilton called the minimum quotas. And that is, you can actually tell Excel that you want to truncate. That means get rid of the decimal. Type equals, TRUNC, open parentheses, and then tell it what cell to truncate. We want it to truncate C2. Close parentheses, press enter. And you can highlight and then hit Control D and it will truncate them all, or you can go to the bottom right corner and drag down. Alright, so now for Hamilton, we need to sum here. So under the minimum quotas, we want the sum of those. 99, and we're trying to give out 100 seats. So remember, Hamilton gives the additional seat to the person with the highest decimal, and state A gets it because they've got 0.36, which is greater than all the other decimals. So 10, 27, 26, 37, and if we do our sum, just to be sure. So I have been clicking and dragging to highlight. You don't have to do that. You can tell it E2, that's where you want to start, colon, E5, and that will do the same thing. It will add them up for you. And we have apportioned our 100 seats. Now, some of our other methods require modified divisors. Actually, all the rest of them will require modified divisors and modified quotas then because of that. So, I'm going to guess one at random. I'm not going to pick one that I know will work. So for Jefferson, instead of 100, I know that I'm going to have to move that down. So let's try 99 as our modified divisor. So I'm going to insert a row here so that I can put in Jefferson modified quotas. Okay, so let's do our modified quotas here. So equals the population divided by, and don't forget to anchor that, this is B10, the modified divisor. So $B, $10. Come to the bottom right hand corner, click, and drag down. So remember that Jefferson also truncates, so 9, 27, 26, and 37, which if we add those together, let's see, that's G2 to G5, we still only have 99. So I need to change the divisor. The nice thing is the way that I have set this up, I can just pick a different number and type it in here. So if instead of 99, if we decide, let's move it down to, I don't know, 98.5. And then let's see what happens here. We still have 9, 27, 26, 37. So we didn't move it far enough. Try another one. Let's move it all the way down to 98. And look at what happens. 9, 27, 26, and 38. So it's kind of nice the way that you set it up here. Okay, so Webster rounds based on the arithmetic mean. And we can tell by looking here, this is 9, 27, 26, 37, which we already know is not going to work. We're going to be one seat short. So let's try a modified divisor of 99 for Webster. So equals, click the population divided by $, let's see, this is actually C10. So $C, $10, and then highlight, Control D. So Webster rounds based on the arithmetic mean. So if it's 0.5 or above, we round up. So this is 9, 28, 26, and 38. So let's add these together, see what we get. Oh, 101. So we actually have too many. So we know that it's going to be somewhere between 99 and 100. So let's, instead of 99, let's do 99.5 and see what happens. We're still at 9. Here we go. This is now going to be back to 27. That is still 26, and that's 38, and we apportioned our 100 seats. And then finally, Hill-Huntington. And we actually need a little bit more information for the Hill-Huntington method. We actually round here based on the geometric mean. So I need to figure that out. So remember that the geometric mean is equals the square root of the product of the two integers on either side of the quota. So this 9.36 is between 9 and 10. And this one we do have to type each one in. Square root of, let's see, 27 times 28 equals square root 26 times 27 equals square root 37 times 38. So the rule of thumb, if the quota is greater than the geometric mean, round up. So 9.36 is less than the geometric mean, so we're going to round down to 9. 27.26 is less than the geometric mean, so we're going to round down to 27. 26.03 is also less than the geometric mean, so we round down to 26. And then 37.35 is less than the geometric mean, so we're going to round down to 37. Well, we can probably guess when we add these up, that's going to cause a slight problem here. So too small, we need to move down from 100. So I can try 99, just like I did before with all the other ones. And that means I'm going to need some new modified quotas. Okay, equals the population divided by $D, $10, since that's where I put my modified divisor. And from here I can just highlight down, Control D. And then let's see what happens. Remember the rule of thumb, if the quota is greater than the geometric mean, we round up. So here the quota is less, we're going to stay at 9. Here the quota is more, so we'll move this one up to 28. Here the quota is less, so we'll stay at 26. And here the quota is more, so we go up to 38. And you see that causes a problem because now we're at 101. So let's just adjust this, and my quotas will adjust automatically. So now 100 for a standard divisor didn't apportion to too few seats. 99 as a modified divisor apportioned too many. So it's got to be somewhere between those. We can try 99.5 again. This one is still less than the geometric mean, so round down. This one is back to being less than the geometric mean, so round it down to 27. And then this one is also less, so we can round it down. This one's more, so it rounds up, and there we go. We have all of our apportionments.